only through the link. يعني لو عملتوا سيرش ما راح يبين. يعطيكم العافية. Today is Tuesday 23rd. Today inshallah يعني it will be the last lesson in astrophysics. نضل نحل شوية أسئلة مع بعض. فجزء اليوم شوي نطول، جزء ناخذ لنا ساعة ونص تقريبا أو شيء زي هيك. عشان هيك اليوم ما عملتش جريد 11 عشان ما يدخلوش على الخط معي. عكل. Today is Tuesday. احنا كنا بنعمل gravitational forces. أذكركم شو اللي حكيناه until now. قلنا the gravitational force or the force of attraction between any two bodies is given by negative, which means it's attraction, G, which is the universal gravitational constant, times the first mass, the second mass over the distance between the two objects. And remember, it's not from the surface to the surface, but it's from the center of gravity to the center of gravity. Second thing, if you want to find the gravitational field strength at a point, this is the gravitational field strength always for planets or for stars or for galaxies, but not for human. I know if you want to find it for human, you can mathematically, but it's non-common sense. But like too small, not taken into consideration. G, the gravitational field strength at a point is given by negative, which means attraction, G times the mass of the planet that we are trying to find the gravitational field strength of that planet over the distance squared between the planet and that point that you want to find the gravitational field strength at that point. The gravitational field strength is radial, which means it acts like a radius of a circle, and it's always attraction, there is no repulsion. Now, today we want to introduce new quantity called gravitational potential. This quantity was not given in the syllabus before, so you will not find any past questions about the gravitational potential. Before I write, let me just revise with you the units. Here it's Newton, here it's Newton per kilogram. Okay. Now, if we want to define the gravitational field strength at a point, بنقول the gravitational field strength at a point equal force per unit mass. مظبوط؟ لا. yes. Okay. مظبوط هاي Newton per kilogram for force per unit mass. Also, the gravitational field strength has another definition. بنقول the if you want to write a new title, let's write the title gravitational potential. It's a new title that it was not included in the syllabus before. The gravitational potential, what is it? Before I start mentioning what is the gravitational potential, I want to relate to the gravitational potential to, let me write the definition of gravitational potential. What is the gravitational potential? The gravitational potential at a point is equal to the work done per unit mass needed to move an object, certain mass, from infinity to that point, from infinite distance to that point. Now, this is the definition of the gravitational potential. If you write it in math, it will look like this. I will rewrite all of these later on because we need them. But the gravitational potential برضه they call it V. تذكروا V مش قلنا electric potential. تذكروا برضه كمان they call it V لأنه potential فpotential is V بس مش voltage يعني اسمه gravitational potential. هذا كان في electricity اسمه electric potential. Okay. So V is how much energy work done per unit mass. The units, this is joule, this is kilogram, so this is joule per kilogram. طبعا it has another unit, we will see it بعد شوي. So this is the electric potential, sorry, the gravitational potential at a point. فتخيلوا معي, let's say here I have Earth. Let's understand this point. Hi Earth. Now, if there is an object here at infinity it's very far. So we consider the gravitational potential here zero. Okay, if this is infinity, we consider it to be zero. Now, if you want to bring it to somewhere to this point, then the gravitational potential at this point is equal how much energy did you do and how much mass it was the object, how much mass it was. Okay. So طبعا again we put negative because it's attraction. بس مش عارف اذا كاتبينه هون نيجاتيف مش كاتبينه هون نيجاتيف. جول بير كيلوغرام. اوكي. هي it's always negative لانها it's attraction. Okay. But this is what do you mean by the gravitational potential. So you want to know what is the potential at this point. You need to know how much energy is needed to bring this mass from infinity where there is no potential to this point. You need to do some work لأنه there is attraction, so you are pulling at certain distance, so there is work. Or sometimes they write energy. طبعا this energy is called the gravitational potential energy. Okay. Then. Now, what do we really mean by the gravitational field strength in terms of gravitational potential? بنقول the gravitational field strength is هم كاتبين how quickly بس بالحقيقة هو ما في time فمش عارف ايش كاتبين how quickly. أنا بدي أكتبه زي ما أنا فاهمه وتقول it's the change in gravitational potential over a certain distance. So G is how much the voltage is changing, sorry, which voltage, gravitational potential, in how much distance. So if you have an object, let's say this is object, it's a satellite, it's a moon, it's a planet, it's anything. It's changing position from here to here. If you calculate what was the voltage, the electric potential here, if you calculate what's the electric potential at this point, you take the difference and how much distance there, this ratio is the gravitational field strength. For the gravitational field strength at one point is the difference between these 2 points over how much distance there. هلا let me find V as a subject for formula. If you want to make it, طبعا in the book they are writing it dV by dx. It's okay if you write dV by dx. Again, it's negative, okay? Again, it's negative. Again, it's negative. Always negative because it's attraction. So here, if I write it this way, طبعا شو بصير؟ You know, V equal G times distance, let me call it R. R or X, the same. But G is equal to negative Gm over R. So V is negative, sorry, over R squared. So G equal negative Gm over R squared times R, the distance. So R squared with R cancelled out. شو بضل؟ Cancels out. So V is negative Gm over R. This is the equation that we will use it, and I believe that it will be given. It will be given to us. This is given. And remember, the unit is joule per kilogram. If they may ask you to show that these two are the same units, it's easy, you can do it. And if you did not, just let me know, I will do it for you later on. So this is the gravitational potential at a point. هلا now مش احنا كتبنا من قبل انه الجرافيتيشنال potential is how much energy over mass. مظبوط؟ يعني نقدر نقول الانرجي equal m times v. مظبوط؟ طبعا في نيجاتيف هون مش مشكله، بس هو في نيجاتيف. اوكي، فانرجي equal m times v والv we just هي والv هي جي ار، فمن m times g times r اللي هو التشينج ان ذا هايت، فام جي اتش. شايفينها؟ فالجرافيتيشنال potential energy, this is the gravitational او التشينج، هذه التشينج in difference، لانه احنا ما في عندنا gravitational potential energy at a point، فالgravitational potential energy is given by mgh. هي the same. طيب if I put G here in this equation, so the gravitational potential energy بتصير m times, and instead of G it's negative G m over R squared times، خلينا نسميها R، هي نفسها R ودلتا H the same. okay، بس عشان so they will cancel out. إذا the potential energy, the gravitational potential energy is negative G m over R. والunit is joules طبعا. But this is how do we find the change in the gravitational potential energy at a point, negative Gm m over R. I know that it's complicated. We wrote so many equations there, so I will try to summarize them just to let you know what are the most important equations that you need to remember. Starting from the beginning, the gravitational force is negative G m1 m2 over R squared. The gravitational field strength at a point is negative G m over R squared. The gravitational potential is negative G m over R. And the gravitational potential energy is negative G m over R. These are the 4 equations that are required from you to know them. طبعا this is a Newton force. This is a Newton per kilogram field. This is joule per kilogram potential. And this is gravitational potential energy. This is gravitational potential. This is gravitational potential energy. Now you can check what is the relation between these. Now this and this, what is the relation between them? If you know the voltage and you want to find the energy, then the voltage is just the energy divided by mass. مظبوط؟ هلا كتبناها the first one. Or if you want the opposite, or if you want an energy, when it's the voltage, just multiply by the mass, because this is the missing. Now here, these two. Now this is the relation between these two. The relation between this and this. What is the relation? Hey, V equal energy over mass, or energy equal V times mass. Now the relation between these two. Let me use another one. These two. What is the relation between them? G is equal to V but divided by R, or V is equal G multiplied by R. Okay? But this is how we would take these into consideration. This is the gravitational potential. لما قلنا if this is the Earth and the gravitational field is coming into the Earth from all distances, we said this line represents equipotential line. So this means if you find the gravitational potential at this point, or at this point, or at this point, it will be the same. If V is the same, then you don't need energy to transfer an object. If the object is here and it is spinning over this gravitational potential, you don't need energy. هذا اللي بيصير. انتم متخيلين انه satellites, they are orbiting Earth all the time. They need energy. If they need energy, from where they get it? They don't need energy. There is no change in the gravitational potential energy there, since they are at the same distance from Earth, so their gravitational potential is the same. But if you want to move a satellite from this orbit and you want to move it to this orbit, صفة different, لأنه the potential at this orbit is different than the potential at this orbit. So you need to take, if you want to know how much energy is needed to move from this orbit to this orbit, you take just only how much there is a change in the gravitational potential times the mass of the satellite that you are doing it. طبعا either it will be energy plus or minus, depends if you are going away. Then it's harder because there is attraction. So if you are coming closer, it's easier. So energy will be plus or minus, depends on whether V1 is greater than V2 or V2 is greater than V1. Depends the motion to V1, from V1 to V2 or V2 to V1. Simple calculation. And I don't know how much they would be tricky. Unfortunately, there is no past question. There are no past questions, but there is some questions in the exam practice. We will solve them together. بس هلا خلينا نشوف. There is one example in the book on page 172. So one example there, page 172. Let me take a photo of this because it will make a okay. Page page 172. If you have your book, please open it to page 172. There is a word example. We want to read it. It's already solved, I know, but just let's see how the wording problem could be. There is a work example number 1. We did very similar one, so I don't want to solve it. But here, work example number 2 is an example. Page 172, example 2 هذا. I'm going to calculate the gravitational potential. Potential, not potential energy. So not E, potential. V. Calculate the gravitational potential caused by the Earth at a distance of geostationary satellite which orbits at a height of, this is the height above the surface, 35,800 kilometers. He gave us the radius of Earth. It's 6,400 kilometer, and they want to find the gravitational potential. It's negative Gm over R, V negative 6.67 times 10 to the power negative 11 times the mass of Earth. It should be given, this is mass of Earth. Okay, they did not give it here. It's written in the question. شكله they depend on the question above. حتى يعني they created a new mass. Example فوق كاتبين الماس 6.01. Here they wrote it 6.02. 6.02 times 10 to the power 24. This is the mass of Earth, not of the satellite. I don't care about the satellite, because not the satellite is doing this gravitational potential. Over R. R is 35,800 plus 6,400. But remember, it's kilometers, so multiply by thousands. The answer given there, it's negative 9.52 times 10 to the power of 6 joule per kilogram. They wrote it megajoule per kilogram. The same thing. Okay. Okay. Now, they would ask you to compare between the gravitational field and the electric field. Let me write like this. Gravitational field and electric field. And let me add the magnetic field. Now, if I ask you, what is the field is equal to? In the gravitational, قلنا G equal negative Gm over R squared. In the electric field, قلنا E is equal, without the negative, K Q over R squared. And here, we did not calculate the field by itself. ما أخذناش equation. يعني there is an equation we did not take. If we take about the force, the electric force, here we said F equal negative G M over R squared. Here there is no negative, K Q1 Q2 over R squared. So both, they obey inverse square law. Both are directly proportional to the product of the mass or product of the charge. Here طبعا لا احنا كتبنا F equal QVB أو ILB if we are talking about current. طبعا في ساين ثيتا مش عارف شو هدول ما لهمش دخل. الحقيقة they did not the book is not mentioning this but I want to mention it on purpose. Now the gravitational potential, the potential. Here we said the gravitational potential lower V negative gm over r. Here without negative kq over r. And here there is no أصلا the word magnetic potential. ما في شيء اسمه magnetic potential. Okay. Moreover, do you need this? Well, I may erase it. Okay. It's written there على YouTube. If you go back, you can pause it and see it there. Now, if I want to know the energy, here we said the gravitational potential energy is negative Gm times m over r. Here the electric energy is V over Q, V times Q, V times Q. Here if I want to write it, on V بس times M. Yeah, V times M, هون V times Q. هون فيش شيء اسمه magnetic energy. Okay, أقول لك. What I care about it here. If I want to make real comparison between them, بنقول here, if I want to talk about the force, well, here it's the weakest force. Here it's stronger. Both are stronger. Only the gravitational is the weakest. Here the force is always attraction. Here could be attraction or repulsion in both cases. North and north they repel, positive and positive they repel. But here it's always attraction, whether whatever it is. Now, if I want to talk about the field in more details, not only the equations, field, the field here, it's radial. Here it's radial. Here it's not radial. No, not radial. Here it could be uniform, could found to be uniform, could be uniform. Here could be found to be uniform, could be. Could be uniform. Here it's يعني almost impossible to find a place where we have uniform magnetic field. For the gravitational field, it could be uniform when we are talking about between close to Earth's surface. زي ما شرحت المرة الماضية, close to Earth's surface, the field could be considered to be uniform. If you are taking over a small area, and let's say this is there, if you want to find the field over this area, yes, it will be attraction. So it's constant direction and it's constant value. In fact, if you look very far, it will be like this. Over this area could be uniform. Here between two parallel plates, between them it's uniform. Maybe at edges it's not uniform, but at least between them is uniform. Here there is no way to find uniform إلا إذا كنت فرضا هون north وهون south وهذول big poles وبس هون بس يعني هون ببلش يعمل هيك. Could be يعني بس very hard to find such a uniform field in magnetic field. Okay. طيب. Now I want to see. Okay, I need to recharge my laptop. I want to see an option. Okay. Now, we said the gravitational force is the weakest force ever. Now, if I want to take a question, expect such a question in the externals, although they did not get it, but expected. Now, I want to write it in uh, maybe two parts. Yes, two parts are enough. Question, you know, uh, A, calculate the electric force between a proton and an electron, proton and an electron in a hydrogen atom. Hydrogen atom, they give us the radius of the atom is 1 times 10 to the power negative 15, no, 1 10 to the power negative 10 meters, and the radius of the nucleus is 1 times 10 to the power of negative 15 meters. So this is basically the radius of the nucleus is the radius of the proton, because the proton has only one, the nucleus has only one proton, صح? So this is the size of this is the radius of the proton. But the radius of the atom, it means the distance between the proton and the electron. So this is what is needed, not this. So he may give you these two just to trick you. You don't need to use this, you just need to use this. Okay? Now, the electric force equal negative K Q1 Q2 over distance square negative ما في negative تعودت على negative sorry, there is no negative. Okay, K 8.99 times 10 to the power of 9 times the charge of an electron or a proton is both the same, 1.6 times 10 to the power negative 19 over the distance between them, which we said it is the radius of the nucleus. Of the atom square. The radius of the atom square. Can you help me doing the calculation? 8.99 10 to the power of 9 times. And I get the answer 2.3 times 10 to the power of negative 8 Newton. I think this is acceptable, and this is considered to be strong. Why? Because we're talking about protons and neutrons. The force is not the same as on us as people. For people, this force is too small. But for an electron or a proton, yes, this force is really big. موافقيني هلا؟ Easy? Same calculation? Okay. Now B. At what distance the proton and electron must be so that they have a gravitational force equal to this force, the force that we calculated. Yani, at what distance, if you want, yani I could ask it in a different way. I could ask you calculate the gravitational potential, the gravitational force between them and the electric force between them and compare. بس انا بدي اساله بطريقه ثانيه، اقول calculate the electric force. Okay, this is the electric force. This is real. Now, at what distance the proton and the electron must be to have the same? By logic, it should be بالنسبة لي much less than this number. ليه؟ لأنه قلنا the gravitational force is the weakest force. So they have to be very close عشان تكون the gravitational equal to the electric. Let's calculate. Now here I want to know R, distance. So the F equal negative G M1 M2 over R squared. The force is the one that we want. 2 point قديش طلع؟ 2.3 times 10 to the power of negative 8 equal negative. If you put it here ولا لا عادي. For the force or for the field, it's okay if you don't write it. For the potential, you have to write it. Okay? For the potential, you have to write it. But if you don't عادي. I will not put it لأنه if I put it, it will be negative. فكيف بده يطلع معنا radius negative وناخذ square root. I will remove the negative. 6.67 times 10 to the power of negative 11. This is G. The masses is not given here, but they are given at the end of the exam. So they will not be given in the question. So you have to go to at the end of the exam, you will find the mass of a proton 1.67 times 10 to the power of negative 27. The mass of an electron 9.11 10 to the power of negative 31. All of this divided by R, let's say squared. Now, R is square root of all of this. Let's do it. So 6.67 10 to the power of negative 11 times 1.67 10 to the power of negative 27 times 9.1. طلع عندي غلط. شغلوا لي يعني. قديش 2.1 هيك طلع معي. صح. لحظة. اوكي صح. إذا R equal قديش؟ 2.1 times 10 to the power negative 30 meter. If I'm asking you comment, بتقول لي it's impossible. Why? Because distance is smaller than the nucleus. يعني البروتون والالكترون must get inside the proton عشان يكون عندهم electric force equal to this force. It's impossible. This is the radius of the nucleus. This is the radius of the proton. So the proton in total from here to here is 10 to the power of negative 15 meter. Now the distance between them, this electron from here to here should be negative 30. How come? You understand? This is just to show you how much the what do you call it? The gravitational force is much smaller than the electric force. and much smaller than all forces in the universe. مش بس. It's the weakest ever. Okay. Do you have your book? الحقيقة أنا ما طلعتش بس خلينا نشوف. Okay. Let's do some of these questions there. Let us do question number 1. Do you have open your book on page 176? 176. Question 1, page 176. Now, which statement is correct? Gravitational field strength is a scalar quantity. شو رايكم؟ No حبيبي، كل الفيلدز are vectors، كل الفيلدز. All fields are vector. البوتنشال هو السكيلر. الانرجي از سكيلر والبوتنشال هلا احنا قلنا البوتنشال هو انرجي اوفر ماس. فذس از سكيلر this is scalar فالبوتنشال از سكيلر. بس all forces all fields any type all of them are vectors. okay. فما في اي فيلد ولا اي فورس سكيلر كلياتهم vectors. Write please this as a note because we did not write it. The gravitational potential is a scalar. While that هذول كلياتهم vectors. So A and B are wrong. Okay, C. Gravitational and electrostatics both follow an inverse square law. صح؟ إذن C correct. هذا one. D. The gravitational both are constant forces. How come? Well, it depends on the distance, صح? But no, D is wrong. Thank you. Let's do question number 4. Others, I will keep them with you to do them. I know there is some calculations. Question 4. Which of the following expressions correctly gives the distance R from a mass M where its gravitational potential is equal to V? يعني هذه which equation for V? احنا بنعرف V equal negative GM over R, so R equal negative GM over V. هذه سهلة. GM over V is in B. طيب يعني هذول I don't think إنه هنا في عنا طيب I need you to do them on your own وبعدين نرجع نحلها مع بعض. بلاش شو اسمه بلاش يعني you lose the trial. بس هلا هون في عنا one point أنا I forget to mention it. You can write it as a note. This was in 11B not 11A. Okay. نقول في عنا شيء اسمه سفيد ستارز. Cepheid stars are variable stars that keeps changing their luminosity periodically over time as they expand and contract. Yeah, this not has nothing to do with the gravitational potential, but just keep this in mind. Wait a second, let me erase this part. Okay. So there are some stars, we call them Cepheid stars. Cepheid stars, they are variable stars. What do you mean by variable stars? And if you are looking to them, their luminosity is not constant. Their luminosity with time, this is luminosity with time. Sometimes luminosity has certain, then it peaks, then it goes back normal, then it gets very low. بس طبعا مش negative يعني مش بالضرورة negative. Let's say from 200 to فرضا 180. Let's say من عقلي, okay? هذول numbers not for memorization, just like this. But luminosity in what? Let's say it keeps changing from lower value to maximum value, keeps changing. Why? The reason. And it's over time يعني now it's 190 بعد شوي صارت هالقد بعدين after the certain time luminosity go back to the same يعني زي كانها wave. It's not a wave but it's just like a wave. It keeps changing luminosity over time because they expand and contract. Now we know that luminosity equals sigma 4 pi r squared t to the power 4. Now the temperature does not change because it's temperature, but the radius, because it is unstable yet, it's in a process where it is expanding then contracting, expanding then when it's expanding the radius is increasing, so we see the luminosity higher, and when it's decreasing, contracting, the luminosity decreases. بالحقيقة this gives us two Doppler effects. Sometimes this star, so these stars show أول شيء redshift when they are going away. When they are going away, this means that as they are contracting, So when they are contracting, they are going away from Earth. And two, the blue shift as they are expanding. So these two are the difference between the normal stars and Cepheid stars. The normal stars have constant luminosity. They always, if they give you redshift, then they are giving you redshift all the time. If it's blue shift, طبعا all the majority of stars they show redshift. Only these stars that they are Cepheid stars, they are variable stars. They are expanding and contracting. So when they are expanding, they show a blue shift. They cannot, they are going toward us. In fact, they are not, they are just only expanding and contracting. اوكي ماشي الحال؟ طيب هيك بنكون احنا خلصنا يونت 5 نشكر الله. هلا today we want to start unit 6. Unit 6 has يعني some calculations we need to learn about. I want to stop live streaming